Now we will start with magnetism. Everything has a history. Similarly, magnetism was discovered in the town of Magnesia by a shepherd boy named Maginus. Maginus is a shepherd boy who discovered this phenomena of magnetism. The first natural magnet which he discovered was magnetite, which is oxide of iron, that is Fe3O4. Hence, magnetite Fe3O4 is the world's first natural magnet. Magnetite is the world's first natural magnet. Now we will discuss about the properties of a bar magnet. In the first property, let us consider that on the surface we have some iron pieces. On the surface we have scrapped some iron pieces. When we have a bar magnet and we bring near to the iron scraps, we will notice that at the corners there will be the most attraction of the iron scraps rather than in the middle of the magnet. Means these corners have the maximum strength in the bar magnet. Hence, these corners were termed as the poles of the magnet. It implies that poles of a bar magnet has a maximum strength in comparison to the whole magnet. Next property is that these like poles always repel each other while unlike poles always attract each other. Its next property is magnetic poles always exist in pair. Means we cannot have a single pole in a bar magnet. We will always have them in pair. Next property is a freely suspended magnet always aligns in north-south direction. And its last property is that repulsion is the surest test for magnetism. We take repulsion as the surest test for magnetism because a magnet can attract magnetic substance as well as magnet also, but it always repel magnet only. Hence, we can have repulsion as a surest test for the magnetism. Now we will discuss about the types of magnet. We have basically two types of magnet. First is natural magnet and other is artificial magnet. The magnet which occurs naturally are termed as natural magnet. Means they are not made by any artificial means. They are naturally occurring. For example, Fe3O4. This is the ore of iron which is termed as magnetite. While artificial magnets are those magnets which are made by artificial means a substance to which properties are imparted, means are induced by artificial means. For example, iron, steel, etc. We always need artificial magnet because these artificial magnets are more powerful in comparison to natural magnets. And the most important feature is that they can be designed in the desired shape and size, which is not possible in the case of natural magnet. Hence, artificial magnets are preferred over natural magnet. Now we will discuss about types of substance. We have basically two types of substance. First is magnetic substance, while other is non-magnetic substance. Magnetic substances are those which are readily attracted by magnets. For example, iron, steel, etc. While non-magnetic substances are those substances which are not attracted by magnet. Means if there is a magnet, they are not influenced, they do not have any reaction towards the magnet kept nearby them. For example, plastic, rubber. Now we will discuss about the types of magnetic substances. There are basically three types of magnetic substances. First, ferromagnetic substance. Next, paramagnetic substance. And third is diamagnetic substance. Ferromagnetic substance are those substances which are magnetized by a magnet to a greater extent. For example, iron, cobalt. When these substances are magnetized, then they have a magnetic field which is parallel to the direction of the magnetic field if suspended freely. Next, paramagnetic substances. Paramagnetic substances are those substances which are feebly, means they are not magnetized more, they are magnetized to less extent. When these substances are suspended freely, then they set their magnetic field parallel to the direction of magnetic field. For example, manganese, platinum, and last is diamagnetic substances. These are the substances which are repelled by the magnet, means sets the direction of magnetic field is perpendicular when they are suspended freely. For example, silver, bismuth. So, we conclude that ferromagnetic substances are magnetized to a greater extent, while paramagnetic are magnetized to less extent, while diamagnetic are repelled by the magnet. Now we will discuss about magnetic field and magnetic field lines. Whenever a bar magnet is kept, there is a space or a region around it where its influence can be felt. That space or region where its influence can be felt is termed as the magnetic field. Hence, the space or region around a bar magnet where its magnetic effect can be felt is called its magnetic field. It is denoted by capital B. Its SI unit is Tesla and CGS unit is Gauss. Tesla is represented by T while Gauss is represented by G. Relation between SI unit and CGS unit is that 1 Gauss is equal to 10 to the power minus 4 Tesla. Magnetic materials like iron filings within the magnetic field of a magnet experiences a force, and this force has a direction which can be determined by a freely suspended compass needle, and the curves which are traced by these directions are termed as the magnetic lines of forces. These magnetic lines of forces always travel from north pole of a magnet to the south pole of a magnet. Like if we have a bar magnet, then its magnetic lines of forces will be traveling from north pole to south pole. These are traced by the directions which is determined by the magnetic compass. These two magnetic lines of forces can never intersect because a tangent drawn to this line always gives the direction of the magnetic field at that particular point. These lines represent the magnetic lines of forces for a bar magnet. Now we will discuss about the structure of a magnet. A molecule is consist of many atoms. Likewise, a magnet is also consist of a number of small magnetized regions. These magnetized regions are termed as domains. These domains are not visible to us by our naked eyes but are visible with the help of microscope. They act as a tiny magnet inside a magnet. Let us consider an example of an iron piece and a bar magnet. And now we will notice that how the domains are different in both these materials. Figure 1 depicts iron piece while figure 2 depicts magnet. We can compare both these structure that in iron piece these are not aligned in the same direction, while in magnet these domains are aligned in a one particular direction. Thus, magnetism in the iron part is temporary. If this iron piece is kept near the magnet, then the domains of the iron piece will also align as of magnet. Now let us see that how can we store a magnet. To store a magnet, we need magnetic keepers, which are specially designed to keep a magnet for a long period of time while maintaining its quality. Magnets have a tendency to lose its magnetism after some period of time. This loosening of magnetism by themselves is known as self-magnetization. So, the pieces of soft iron work as a magnetic keepers so that they have a less self-demagnetization. The magnetic keepers are designed as this figure depicts the magnetic keeper part. Means when the magnet has to be stored, they should be always stored in the magnetic keepers only. Now we will discuss about the magnetic effect of current. The magnetic effect of current was first given by Oersted, and he performed experiment which is as follows. To depict this effect of current, he has taken two circuits in first figure. He has opened the key which makes the circuit incomplete, while in second circuit he closed the key which makes the circuit complete. In first figure, we can see that the key is open, hence the circuit is incomplete, so no current flows. While in figure 2, key is closed, hence the circuit is completed, thus the current flows. As the current is flowing in figure 2, the magnetic compass is also showing the deflection. The deflection in the needle depicts that there exists magnetic field, while in figure 1 the magnetic compass is at rest. So we can conclude that whenever there is a current, magnetic effect or magnetic field is produced. This is known as the magnetic effect of current. In this figure, when the direction of current is reversed, the direction of deflection of the needle is also reversed. Now, we will see that how can we determine the direction of a magnetic field which is produced due to the flow of current. To determine the direction of magnetic field, we will use right hand thumb rule. According to this rule, when we stretch the thumb of our right hand along the direction of current, The curling fingers always give the direction of the magnetic field there. Like if the current is flowing in the upwards direction in this conductor, then the magnetic field is perpendicular to the plane upward. Magnetic field is perpendicular to the plane upward. But if the same current flows downward, then it will be perpendicular to the plane downward. Thus, according to right hand thumb rule, thumb of right hand is along the direction of current, while curled finger are along the direction of magnetic field. By using this rule, we can identify the direction of current if we have known the direction of magnetic field, or we can determine the direction of current.